Good day everyone, and for this lesson is about activity series of metals. In learning the series of metals, please remember the following. First, you have a less reactive metal cannot replace a more reactive metal because there's no reaction that will happen. And the second is that a more reactive metal can replace a less reactive metal and it can make a reaction. So you have to notice that if in the periodic table you'll see that a less reactive metal, of course it cannot replace the more reactive metal. So why? Because there will be no reaction that will happen. However, if the metal is reactive, or it's greater in terms of the reaction, the less reactive metal can be replaced in the reaction. So why do you have to learn this? Because you have to know which of the metals can make a reaction or make a compound. You have to consider the following questions in learning the series of metals. The first thing is what happens to the reactivity of metals along a period. So let me discuss this first to you. The reactivity of metals along a period. So remember that periods in the periodic table are from 1 to 7, and it is from left to right in terms of the direction. So let's have, for example, here the period 3, or the third period, starting from potassium, going to gallium. So that's from left to right direction. Now, if you notice below, there is an arrow indicating from right going to the left. It says there that it increases in reactivity. So it means to say that from gallium going to potassium, the reactivity or the metals are more reactive in terms of uh, the right to left direction. So for example, gallium is lesser in reactivity if we compare that to potassium, which is actually on the far left of the periodic table, or in the group 1. So the next next period, for example, you have the period number 2, or the second period, from sodium to aluminum. So you have 3 examples there of the elements. So let's suppose we are going to look at the period from the direction right to the left. So to compare that, the aluminum has less reactivity than the sodium. So the same thing with the rest of the periods. So the same pattern. So if going to the direction is from the right going to the left, there will be the greater reactivity or increase in reactivity. So it means to say that those elements in the if you notice the from the greater left side, you have the potassium, the sodium, lithium, rubidium, cesium. You have magnesium, calcium. So these elements actually reacts greater, than those on the right side elements. For example, you have there the aluminum, zinc, gallium, so and so on. These elements have lesser reactivity than those of the elements on the left side. So you have to notice also, to make it as your easy reference, you have to look at the arrow, indicating of the reactivity, in terms of periods. So let's proceed to the second question. What happens to the reactivity of metals down a group? So in a group or family, you'll notice the arrow from the top to the bottom that it increase in reactivity. So in opposite direction to that, if you're going to start from the bottom going to the top direction of the group, it will be lesser in reactivity. It's opposite. Okay? It's almost the same thing with what I've explained a while ago along a period. This time, uh, in a group, especially down a group, going down. Like for example, let me give you the example. In the first group, lithium, sodium, potassium, and so on, going down, it means that the reactivity increases. So this, for example, cesium, francium, okay, so these elements are more reactive than those at the top of the group, like the lithium and sodium. Okay, so it's the same pattern for the rest of the group or families in the periodic table. All right. So let's proceed to the third question, which is the most reactive metal. If you notice that the increasing in reactivity and the lesser reactivity of the element makes the metal, okay, you're going to know the metal if it is reactive. Okay, so it means that you're going to look at the arrows again as your indicator or as your reference. And so again, those elements with increased reactivity, okay, so with a greater amount of reactivity, okay, so especially those at the left side of the periodic table, these elements are more reactive than those on the left. Okay, so the same thing, those at the top portion of the periodic table have less reactivity than those below or at the bottom. Okay, so because if you're going to understand or review what I've told you a while ago, that along the period in down a group, okay, so following also the arrows indicators, okay, so the direction, okay, you'll know the metals that are more reactive. Okay, so for example, I'll give an example like calcium is more reactive than gallium. Okay, so another, you have sodium. Okay, so let's have the period in the period. Okay, in the period, sodium. That's the second period. Sodium is more reactive than aluminum. Okay, why? That's because we are talking about the reactivity in terms of the period. Okay, and in terms also for the group, for example, copper is lesser in reactivity than gold. All right. So that's everything about this. Okay, we proceed for the next subtopic. All right, so in this subtopic, you're going to focus regarding the group or the family and the reactivity of the metals. And there are examples of elements. Okay, you also see here the symbols of the elements, and you have the group number. So take note, we're focusing about the groups. Okay, so although I've already explained to you, okay, and previous explanation that the series of metals or reactivity also happens in periods. Okay, so this is one of the patterns in the periodic table, okay, that you're learning right now. So you have there also the arrow, okay, indicating, okay, so most reactive and least reactive. Now these examples are arranged already. Okay, so these are the elements that are derived from the periodic table and arranged this way, and it's already arranged from the top, okay, going down to the least reactive, or the most reactive to the least reactive. So it means that going down, there is a decreasing chemical reactivity. So for example, here you have potassium. The symbol is K. The group is in number 1. So if you would like to look at in your periodic table, you can see that, right? So you have the most reactive potassium. Compare that to the zinc. Okay, so the zinc belongs to the group of transition metal. So it means that potassium has greater reactivity than the zinc, okay? Or of course with the iron, if you're going to compare that. So going down, so it means that the reactivity of this metal, for example the copper, silver, gold, and platinum, has lesser reactivity than those at the top of the examples. Okay? You're going to notice also that the group number, you have 1 for the potassium belongs to first group, sodium also in the first, and lithium. Okay? So it indicates that those under the first group of the periodic table, I think I've already mentioned that also from the previous explanation, okay, because they are on the far left of the periodic table, so they have the most reaction, okay, or reactivity. Okay, so this comparing this to the next group, okay, you have calcium and magnesium. Okay, so if you notice the group number, okay, if you're if it's going to the right direction, so it has lesser, okay, reactivity. It's the same way here in these examples. So those at the top, okay, are in group number 1, most reactive, and then calcium magnesium is in group 2. Then you have aluminum, okay, below the group 2 you have aluminum belongs to the group 3. Of course, you're going to take a look at the transition metals. The transition metals, you have the zinc, iron, and so on. Okay, below that, you have the copper, silver, gold, and platinum. Why the copper, silver, gold, and platinum are at the least reactive? Because if you notice, they are going to the right side direction of the periodic table, which has or they belong to the right side, which has a lesser, okay, reactivity of metals. Now you have here, or if you're going to look at these examples, you have hydrogen. Okay, so this is a non-metal. Now uh, this indicates how the elements are going to react with this non-metal, because as I've also told you a while ago that you're learning reactivity of metals because you want to know, or I would like you to learn if the metal will react to other metals or non-metals, okay, or especially for the non-metals, and it can form, or you're going to know if it can form a compound, right? So let me give you an example. For example, hydrogen and the potassium. So the question is, do you think there is a reaction that will take place for combining the potassium, or putting potassium to the hydrogen, which is metal plus non-metal? Right? So of course there will be a reaction. Why? Because the main reason is that potassium has greater reactivity and hydrogen is below the, or it's actually getting to the least one, so there will be a reaction for that, or it can replace, actually. For example, let's have the copper and then magnesium. So since the copper is at least reactive, and the question is, do you think magnesium can be replaced by zinc? It's not. Okay? It cannot takes place because the zinc is at least reactive than magnesium. So what if, okay, we're going to compare that, okay, magnesium and sodium. So do you think that magnesium can be replaced by sodium in terms of the reactivity or reactions in the compounds or forming compounds? It's a yes. Why? Because sodium is at the top. It's more reactive than the magnesium, and it can also replace the zinc or aluminum. Okay, all of those examples here at the bottom part. Okay, so you have to uh, know this series of metals or reactivity of metals because it will help you, as I've mentioned already, to know if a certain metal or a certain element combined with another element can form a compound, okay? Or can we replace the, if for example in the laboratory, or if in a certain situation you don't have the element that you need, and can we replace or can we substitute another element for that? Yeah, so you're going to look only at your periodic table, look at the look at the group where they belong, and take a look at the group. Okay, if this can be uh, more reactive, okay, especially for those group 1, 2, and 3, okay, than those with the transition metals. So the same thing, okay, as I've explained, that if you can also compare that in terms of the periods. Okay, you can take a look at the periods. Okay? If uh, you can make a replacement or change the element to another one, and would there be a reaction? Okay, so that's everything for the activity series of metals. Thank you very much, everyone, for learning with me regarding the activity series of metals. It's only one of the patterns of the periodic table.